So as you know, the conformal mapping, where you map from a zeta plane and to a z-plane. And then in z-plane as well, we have the real axis and we have imaginary axis. In z-plane, we have the real axis and we have the imaginary axis. Okay, so when we do that, so the one here can be a circle. Here, if you map it, you can have a airfoil. Okay, and there is a relation between z is equal to c squared over c. So now let's see different cases. The first case is that we have the first one. And then here we have the xi as the exponential I theta. Okay, so this one is a circle. And this is the xi plane. This is the xi plane. And now next we move on. So we are adding second part, which is this arm. As you can see, it changes. And then when we add them together, so you will have a shape something like this one. But all the variables. Okay, so now let's see what happens here. So we have this z-plane, which is the circle, and then we have the z-plane, which was a line. So let's see first the z-plane, it was exponential I theta, and then now we have here the c squared is equal to 1. So in that case, you will have the exponential I theta plus the c squared is 1 over exponential I theta, and that will be equal to cosine theta plus I sine theta plus cosine theta minus I sine theta, and that will be 2 cosine theta, and this is real. Okay, so in z-plane, we have a real and imaginary axis, but in z-plane, we have only a real part. Okay, so that means that in z-plane, you will have a circle, but in z-plane, you will have only one axis, which will be zero imaginary axis, but only will have the real axis. But if I change the value for c squared, I can make a c squared value less than 1. Okay, so now you will have the exponential I theta plus then c squared times exponential negative I theta. Okay, so in that case, this will be a circle, this will be a same circle, and this will rotate this way, and this will rotate that way, but you have here the scale. Okay, so at the end, so this will be the radius of this circle. Okay, so in that case, you will not get a line, but you will get a mixture of this real and the imaginary axis. But if you change the c square value one more time, so here you have the c square value very close to 1. Okay, and then here the c square value Then you can see that you will get another curve. But in all these cases, we can see that this one, okay, is centered at 0, 0. Okay, now I can make it to be centered at a little bit up. Okay, so now you will have the vertical shift. And if you add the vertical shift, the zeta becomes some imaginary number plus then exponential I theta. Okay, and then you will have the second term as the c square over some imaginary number plus exponential I theta. Okay, now it is not a circle, but closed circle. So if you do that case, you will have a number. Or you can shift more. You see, I can shift more and I can have a more camber. Now I can do a vertical, instead of vertical shift, I can do now horizontal shift. As I do horizontal shift, I am getting leading edge and the trailing edge. So this one has the leading edge and trailing edge. Now this one is some real number plus the exponential I theta. Okay, and I can do more. I can get a combination of these. You can see that there is a shift in both ways, horizontal and the vertical shift. I'm getting a Jukowski airfoil. Okay, so now the C is some real number plus imaginary number plus exponential I theta. But it's not always you are lucky, but sometimes we can get a funny airfoil. Okay, so it means that the choice of a parameters important. Okay, so it means that we are not always lucky. That's all.